All right, welcome everybody. Today we're going to be talking about some more advanced topics in C Sharp as well as Unity. This is going to be a little bit more dense than our previous presentations, so please feel free to stop me at any time. Just raise your hand, ask questions in the chat, or just get on the mic and yell at me to stop. Any of it works. All right, so first off, we're going to be building some foundations in some C# topics, and then we'll move into the more Unity specific stuff towards the end. The first thing we're going to be talking about are generics. If you are familiar with C++, these are the exact same as templates. And basically what generics allow us to do is allow data types in classes that we define to be generalized, so we can pass whatever arguments we want to them. So for example, if I were making, say, a linked list data structure and I wanted it to store integers in the nodes, that's fine and all. But then if I say wanted to make a linked list with doubles instead, I would have to make an entirely new class and basically rewrite all that code. But then the only difference would be I would change int from double. That's a big waste of time and effort. What we can do is we can make that class generic. And so we only have to write the code once. And so that allows us to reuse the code for whatever data type we want. So then what that does for us is makes our code reusable, which is something that you should always be striving for as a programmer. It makes the code more type safe and also increases our performance. Not by a ton, but it is something that we should always consider. So what do generics look like in C#? It's pretty simple. You can see here, this is an example from Microsoft's documentation. They have this class that they have defined called generic list. And then they have these little angle brackets here. And then they've made their identifier here T. You can name this whatever you like. They just happen to call it T. But this right here represents the data type, basically. And so this data type is the data type that we're going to be using throughout the rest of this class. And then in their example here, they have one single function called add. And then instead of having, say, like int or double here, they just have T, because that is our generic type that we're going to be passing to it. And so then when we have a generic class, we always have to pass it a type when we instantiate it. And you can see that down here in the main function. So we have generic list, then angle brackets, inside the angle brackets int. So now this instance of this object is going to be contain integers. Here we have it as strings. We can also pass in custom classes that we make ourselves, and it'll work just fine. All right. And so we have some do's and don'ts when it comes to generics. You want to use generics when you have standard data structures. C# actually comes with a lot of these built in as generics, like lists and dictionaries, arrays, all that. So you don't actually have to make them yourself, which is really, really nice. Or when you want a user to decide what type of class they're using for them, what type for a class they want to use for themselves, or when you are using one class to handle multiple types of data, or when you want to reuse a collection of classes often. Now, you don't want to use generics basically when your code relies on some specific functionality, whether that be like functionality of the data type or of other objects. Generics just don't really work well when the code has to be highly specific. We have any questions so far?
Oh, I have a question.
Yeah.
So with generics, it's supposed to be that they're able to take inputs of anything, say any variable or a existing class like rigid bodies and whatnot.
Yes.
Okay.
Yeah. So then in these angle brackets, you can pass whatever data type you want, basically. And then you have to make sure that when your class doesn't rely specifically on any kind of like specific functionality of a data type. So like, I can't have this code, work with a string function, let's say. Otherwise, that's just not going to work. Then this class can only work with strings.
Okay. So they pretty much, so in there, where the empty semicolon says next to inputs, I'm guessing that's where the code would run.
Sorry, where?
Yeah, 1 minute.
Like here?
Yeah, is that where we type the code in?
Yeah, so this was just like this is just like a quick example from Microsoft. This code doesn't actually do anything at all. But
Okay.
yeah, this is where your code would be. And then you have to make sure that whatever code you do write, it doesn't rely on specific functionality from any sort of data type. So like in the case of a linked list in an add, you would just simply add it, like you would store that data in the node and that will be it.
Okay, I understand.
All right. Any other questions? Okay, I will take that as a no. Delegates. This I don't expect as many people to be as familiar with. Delegates are a type that represent references to methods with a particular parameter list and return type. Basically, they are references to methods. And what they allow us to do is they allow us to pass methods as arguments to other methods. This is really helpful for for callback functions, and then coroutines, which we'll get into later. So any accessible method can be saved in a delegate, including anonymous and lambda expressions, which are methods that don't have any sort of name tied to them. So here is a quick example of how you make a delegate and how to use it. Up here, we are declaring a delegate of type called del. And notice here that del, we are saying, has to have an input of a string and a return type of void. So that means that whatever function we store in del, it better take in a string and return void. It can't accept anything else. And then down here, we're actually instantiating the delegate. So the type is going to be the name of the delegate that we defined. And then you give it a name like any other variable. And then you pass to it the name of the method. And then down here, this is not the greatest example of how to use a delegate, but it shows how it works, how you call them. You take the name of the delegate that you gave it, and then just pass in your arguments. As I said, normally these are used for callback functions. This is just purely for educational purposes. You would never do something like this in an actual project because it's pointless. Do you have any questions? Can you assign a different function to handler? I believe you can, yes. Because handler can take in, it's basically like a pointer to a function. You can think of it like that. So you can reassign it as long as the function signature matches the delegate function signature, it should be fine. it's kind of like a variable. I would say it's more in line with like a pointer, but like C# doesn't have pointers. Yeah, I mean, I guess it's kind of like a variable almost. But yeah, you can think of it as a variable that just holds a function. Yeah, I don't expect you guys to ever actually make your own delegates. In fact, oh, no, that's later. Okay, hang on. I have to go through this first. You know how I said that function signatures have to match the delegate signature? Yeah, that's not always true. So there's a thing called it's called variance. It's very similar to polymorphism, actually, that allows us to use more derived or even less derived return types for our delegates. I don't know why you would ever trust me, Jacob. I don't think I've ever said I was a trustworthy person. So here's an example of what's called covariance using a more derived return type. So in this example, we have a class called mammals, and then we have dogs, which is derived from mammals. That's what this little colon here says. Dogs is derived from mammals. And then we declare a new delegate that has the return type of mammals, and it's called handler method. And then we have two functions here, mammals handler, which returns mammals, and then dogs handler, which returns dogs. This line here, we're passing mammals handler into a new handler method. And now this is fine. This is what we've already seen before. But this line here is a little bit different. We're passing dogs handler to handler method, which expects mammals as the return type, but dogs handler returns dogs. And we're allowed to do that because of this covariance. Is that clear to everybody? What's been going on in the chat?
I'm a bit confused with the static void test. So you initiated handler methods to equal mammal handler, and then.
So we have handler method here. This is the delegate that we declared up here, right?
Okay.
And then we're making two of them here. So we
Okay.
have handler mammals. This is just the name of, this is basically just a variable. And then we're going to pass to this variable mammals handler, this function up here, which returns type mammals.
Okay.
Then down here, we also have another handler method delegate called handler dogs. And in this one, we're passing to it this function dogs handler. But dogs handler doesn't return mammals, it returns dogs. But this is still allowed because dogs is derived from mammals up here.
Okay. I think I got it.
Serge, yes, Ben, there actually is. I think that is my next slide. No, it is not. I lied. I don't know my own slides, and I was looking at this like an hour ago. All right, multicasting delegates. We can combine delegates using the plus operator. This is called multicasting. So when you invoke a multicasted delegate, what happens is it'll just invoke all the methods that have been associated with it. So then you can see over here, we have hidel, which has this hello function, bidel, which has goodbye, multidel, which has a combination of hidel and bidel, and then multi minus hidel, which is going to be hidel and bidel minus hidel, leaving us with just bidel. Yes, Ben, you can add them. So then what does this look like in code? So high-del by itself just prints out hello. Bi-del by itself just prints goodbye. Here we have multi-del where we're adding high-del and bi-del together, essentially. We're multicasting them, and it invokes both of them when we invoke the multi-del. And then we're using in my multi minus high-del, we're using the minus operator to remove a function or a method that was associated with multi-del. So we're removing high-del from multi-del, which just leaves us with goodbye. You guys good with that? Any questions? Does order matter? I would assume so. So like if you swap the order of high-del and bi-del, then I believe it would do bi-del first and then high-del. Custom del declaration. Yeah, I think so. Again, these are all examples that I pulled from Microsoft, from their documentation. I'm pretty sure they declared it somewhere. I just didn't include it because I'm lazy. Okay. If there are no other questions, I will be moving on. I think this is the slide. Yes, here we go. Here's your answer to your question, Ben. Generic delegates. We have 2 of them. Technically, actually, we have what would it be? 32, 34 of them, actually, technically. But they're broken down into action and func. These are generic subclasses of delegate, and these can be used anywhere a delegate is used. So, you know, you don't always have to make your own delegate. You can use action or func. What action does is it holds methods that return the type void, and func delegates hold function methods that return a specific type. And these can take up to 16 different arguments, and they're generic because, you know, these types can be whatever the hell you want. They're generic classes. You can pass in whatever you want. And then I said there's technically 34 of them because if I mathed right, 16 arguments, there's literally like 17 overloaded versions of both ACK and func. But don't worry with those details. You have any questions? All right, let's move on. And then you can find out more about delegates by going to Microsoft's documentation, where I pulled all these examples from. So with the C# specific stuff out of the way, we can finally move into the more Unity focused part of this presentation, starting with the coroutine. Coroutines are fucking awesome. I love them. So first off, I need to start this discussion off with talking a little bit about how Unity works. So in Unity, whenever you call a method, that method has to run to completion before the next frame can be displayed. So if you were to do something stupid, like include an infinite loop in a method and then call that method, it'll cause your game to freeze. I definitely didn't learn that the hard way. I'm a good programmer, I swear. Coroutines are, Which game? That happened in Gremlin Garden last year. Several times, I think, actually. Anyways, coroutines are methods that can actually stop their execution and let the frame complete before they resume. And then you can give them different instructions on when they resume. It can be resumed the next frame. It could be resumed after a certain amount of time has elapsed. We'll cover that in a couple slides here. But what this allows us to do is allows us to create functions that run over time or suspend methods that stop and start execution in real time. These are super powerful. They're really good for implementing things like charge meters, timers. I'm going to go over an example in just a second here about fading an object out. So you can, I mean, they're super powerful, but like they're a little tricky to work with at times. And then finally, coroutines, to start them, all you do is just start coroutine and then a delegate where you pass to it a method that returns IEnumerator. So here we have an example given to us by Unity. This code is a little deprecated. It's kind of old. I have a more updated version that I'm going to show you guys in a second. But we have here just a regular function that gets called in update just by calling fade. Now, since this is a normal function, the intent is that the object will fade out over time. But this is a regular function. So this is going to get called, and then it's going to run to completion before the next frame is displayed. So you don't get to actually see this effect. It'll be one frame, the object's there, then the next frame, it's gone. If we turn this into a coroutine, though, we'll actually be able to see this play out over time. And then you can see here the structure of a coroutine. The return type has to be IEnumerator, that it has to be this. And then at somewhere in your code, you're going to have this yield here. And then this is basically going to tell the coroutine when it's supposed to resume execution. We'll go over that in a little bit. I want to show you guys how this all works. I can pull up Unity. Here we go. So here we have, in my update function, I just have input get key down. So when I press F, it's going to call fade. And then I don't need this. That was for debugging stuff. And then it's going to run this. And then we're going to see that this is going to actually just, can this stupid sidebar get out of here? Perfect. This is going to complete in one frame. You're not going to see this effect. See, it's just instant. If we switch this over to the coroutine, though, you can see here I have a yield return statement, wait for 0.1f seconds. We'll go over what this does in just a second. I want to show you guys how this works. And now you can see this effect plays out over time instead, which was the intent of the fade function in the first place. You have any questions so far? All right, take that as a no. So how does the yield work? As I've said before, yield return statements tell the coroutine when they should stop. And then what you put next to the return is basically when it should resume again. So you have three choices here. You can yield return null, which will just resume execution with the next frame. You can yield return a yield instruction, which are the built-in instructions, which will be the next slide. Or you can make your own custom yield instructions. These are a list of all the other yield instructions that we have built into Unity. We have wait 4 seconds. That's going to wait for some in-game time. Wait for seconds real time, which is unscaled time. Wait until, which will wait until the delegate returns true. This is going to require a delegate that returns a bool. Wait while is similar to wait until, except the delegate has to return false. Then there are custom yield instructions. I'm not going to cover that because frankly, I was too tired to. If you would like to look more into this, you can look through the Unity documentation to learn more about custom yield instructions. And then finally, we have Unity events. Unity events are very similar to multicast delegates, actually. Unity event objects hold listeners, and then each listener has a method associated with it. And then you could add multiple listeners to a single Unity event object. And then when a Unity event is invoked, then every listener will call the method that it is associated with. And then we can see just a little example of how this works in your script. Here we have Unity event, my event. Then you add a listener with just this add listener and pass to it a delegate. And then when you call my event.invoke, then it'll invoke all the listeners. There only happens to be one in this case, but you can add as many listeners as you want. And then, of course, if you would like to explore more about Unity events, there's 2 entries in the Unity API. There's a script reference, which basically just goes over this. And then the manual entry, which goes a little bit more into deeper detail about Unity events and how to work with them. And that's all I got. You guys got any questions? Of course, thanks for coming by, everybody.